All right, so we are going to talk about the fuel oil system and starting off a mill. Did I say all right? Every video has to start with me saying all right. I don't know why that is, but it's wired in my brain now. So we start at the fuel oil tank. And then that goes over that levee we built to the fuel oil pumps. And these are positive displacement type pumps. Y'all know the difference between centrifugal pumps and positive displacement types? Anybody gonna help me out? No, okay. So in the centrifugal pump, what you've got is a disc that has vanes cut in it. And as the disc spins, then the fluid gets slung outwards, and that slinging outwards creates pressure. So in this scenario, if the pump is deadheaded, there's a maximum pressure, and as you open up the valve and give the liquid somewhere to go, that pressure falls off. A positive displacement pump is going to move a certain amount of fluid for every turn, right? So it's like a screw drive, like a bore, or it's like a piston pump, like a ketchup pump. It fills up the cylinder, and then it's going to move that cylinder worth of, if it fills up 8 ounces, it's going to move 8 ounces of fluid. It doesn't matter what the pressure is. Because it doesn't matter what the pressure is, that means if you shut off all the valves, that 8 ounces of fluid is still coming, and it's going to find a crack somewhere. So positive displacement pump systems don't really have recirc valves so much as they have relief valves. All right. So the fuel oil pumps, and then it goes underground across the street, and it goes up to the lube oil heater on the second floor. Then immediately downstream of the heater, it is a pressure control valve. And this returns back to the tank. This is physically behind the heater. It's between the heater and the rail. And then that is maintaining 200 psi on that leg of the header. So as we use more oil and pressure drops, then this valve pinches back to drive the pressure back up. And then when you go up a floor, and we got another control valve, and this is maintaining 125 psi. And then you've got the trip valve. Then you got your accumulator, and then you got your trip valve.
Trip valves in front of the accumulator, is it not?
Physically, if you follow the pipe from the accumulator, it ties in upstream. I got busted on this 2 weeks ago, where I didn't know, and I ended up drawing the accumulator on the wrong side of the trip valve. All right, what's the purpose of the accumulator?
To maintain a pressure that you want for the valve.
Maintain the pressure. Well, didn't I just say that the valves maintain the pressure?
It's maintaining 125.
It maintains your surges.
All right, it reacts to surges to maintain the pressure. So the accumulator has a volume of, what, 50 gallons to it, something like that? Inside that guy, there's a balloon. And that balloon, we line up a nitrogen bottle. Nitrogen should be a different color, shouldn't it? So we fill that balloon up with nitrogen, and we set it to whatever pressure we want.
About 90 pounds.
90 pounds is a good answer. You have to set this 90 pounds without any pressure on it. So ideally, you don't have the pump started yet when you get this pressure set. So then you start the pumps. This guy's going to be open all the way. This guy's going to slowly pinch back and drive that pressure up. This guy's going to get your 125, and as that pressure builds up to 125, that balloon is going to compress, and the oil is going to get pushed up into the accumulator. So it's kind of like a water tower, where it's got some fluid stored up in it and some pressure. The water towers use height and gravity instead of using a balloon and nitrogen. So it gets shoved up in there, and so that volume of the accumulator is 2/3 oil. So you got 30 gallons of oil in there, and then you got your trip valve, and then we go out to the actual burner rows. So you got 3 burner rows. Each burner has 5 burner rows. 5 burner rows. Each burner row has 6 burners. The oil is supplied to them in pairs. So when one of those valves comes open, oil starts going there that wasn't going there before. So then that makes the pressure drop, and then it takes a little while for this control valve to get back open and realize what's going on. But immediately, this nitrogen starts pushing that pressure back out and making that 30 gallons up to give this valve time to react. If you don't have this accumulator lined up, then when you light off one pair, that pressure dips down, you don't have enough oil flow going to igniter, and one of your igniters blows out. And so you end up putting one on and losing one, putting one on and losing one, and just chase them. If you line this up with too much pressure, it is just as bad as not lining it up at all. If you have no pressure, then you end up with a solid slug of oil and nothing to push it out. If you have 130 pounds of nitrogen in there, then that balloon doesn't compress at all. You might as well just be pushing against a flange. There have been times that the accumulator that the balloon got leaks in it and got all filled up with oil on the inside. And the real answer there is to shut things down, drain it, and have the maintenance replace the bladder. I think a lot of that was self-inflicted shit because operators were not lining up the balloon before the pressure started, and the balloon was getting all wadded up in there. And a lot of it was just putting too much pressure or not enough pressure and then not getting the right performance and then blaming it on the balloon when there was nothing physically wrong with it at all anyway. But we've learned. We're better. It's continuous improvement, right? But if this isn't working and you have a control room operator that doesn't want to shut down everything and bring maintenance in to fix it, then maybe when they're lighting off igniters, they're gonna try and time it. So right before the igniters, they take this valve to manual, they put extra 10% in there, and then put it back in auto. So that you're leading the loss, you're leading the pressure loss to stay ahead of it. All right, so if we're lighting off igniters, if there's a mill in service and you're lighting off igniters, then there's supposed to be fire in there from the mill. The flame scanners are going to see fire, and the logic says, oh, that's fine, we're supposed to see fire. If there's not a mill in service and you're lighting off the igniters, then it's supposed to not see any fire. And the flame scanners are kind of too sensitive and are kind of bad about seeing the fire on the other side or maybe getting lit off by the adjacent fire. They're not focused as narrowly as the engineers that designed the plant thought they would be. So we have to trick fuck these things all the time. The trick fuck comes in 2 methods. The easier method is unplug it. And the harder method is you blind it, which is unscrew it and point it at something where it can't see the light anymore. So The reason we wouldn't always go with the unplug it method is if it has to know, when you unplug it, it goes bad quality, and the DCS knows it's been trick fucked. Well, if it knows you do both of them on the same side, if alpha 1 and alpha 2 are both bad quality, or no, alpha 1, there's 2 on it. Thank you very much, Al. If the igniter and the main flame are both bad quality, then it goes, oh, whoa, I can't light off. I don't know what that flame is. I'm not going to blow up this thing. So you have to unplug one and then unscrew the other. And it can end up where you've got none of your igniters, none of your flame scanners actually reading during that minute and a half it light off. You also, it has to legitimately see flame within a certain amount of time, or that'll screw up the sequence and it'll shut down. So then, once the valves come open, what other valves are there? There's also air going to this thing, right?
Yeah.
What color's air? I guess air's pink today. So you've got an air valve, and that air goes out to the tip, and the oil. So it's atomizing air. What does atomizing mean?
Break into droplets.
Perfect. So the idea is it's hard to light off oil. You can put out a match in diesel fuel. This is not something that most people have the nerve to do, but it can be done. But if you missed it, and you increase that surface area, you increase the amount of oxygen getting to each bit, and it lights off easier. It's vapors that really light off. Also, if the diesel fuel's at 100 degrees, then it might light off with just a match. Please, kids, be careful. Don't do anything I say. All right. So the purpose of the atomizing air is it joins the oil at the tip of the fuel thing, and then that gives you a good spray, and that makes it easier for it to light off. And then you also have a spark rod that is using electricity and a gap and going and making a white light that you can see through your little glass, and that's the spark that lights it off. And then there is another air valve right there, and that is a purge line. And in the event that it doesn't light off, that your sequence doesn't work, then this guy comes open and it ties in right next to your fuel oil valve so that you don't have 5 gallons of oil sitting in that pipe. It all gets pushed out. And lots of times when that happens, it looks like it lights off really good for a second. All right. What else we got? There's limit switches on the atomizer or on the igniter tip itself. There's one that tells it that the back's screwed on. So when you unscrew the back and clean the tip, if you don't get it jacked all the way in there like it's supposed to, it won't make that limit switch and it won't let them start it. And then there's another limit switch, and there's 2 little pistons. So there's a piston that moves in a little bit right at the beginning, and then there's a larger piston that moves in the rest of the way at the end. And there's a limit switch associated with that last piston, and that has to make. These valves all have limit switches, so the DCS has to know that they actually made their limit. The valves actually have to make their limit in a certain amount of time. Sometimes they're really slow. Most of the time when they're really slow, there is an exhaust vent, and that thing will get dusted up or liquided up. And the new dryers have been doing a better job, and these haven't been the kind of problem they used to be. And also, I think guys have been just fucking throwing away the filters. But the mufflers, you could take them off and after you take one off, don't throw it away. They're free. Oh, they're not free. Somebody's paying for them. But they're down in the shop. We have them. You don't need a special key to get to them or anything. You can just get one that's the right size, screw it on, and replace it. I'll also say that the cut dampers that we struggle against, this is the problem with some of the cut dampers, is the discharge vents getting clogged, not that there's anything physically jammed up with it. All right. So running through that real quick one last time. So we don't have anything running. We charge the accumulator with 90 pounds. We start a fuel oil pump. The recirc line, the pressure control line, it starts out wide open and it slowly chokes back and builds up to 200 pounds. Then this guy is maintaining 125 pounds downstream. So it stays open until it gets up to 125, then starts pinching off and tries to maintain that as that goes above it. Then we have this trip valve. I mentioned it, but I didn't say what it's for. All right, the trip valve, there's a 2-minute leak. The trip valve exists so that in the event that the unit says, whoa, 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 no fucking fire, boom, some safety's been violated, it cuts the PA fans, it cuts the mills, and it cuts this igniter valve, it cuts off all the igniter valves, and it's a way of saying no fuel in the unit, purge it out, start over. To make sure that we're holding, there is a 2-minute leak check that happens. So there is a 10-minute purge that a good CRO will time so that you guys aren't especially aware of it. And then there's a 2-minute leak check. And then that leak, so this guy opens, we measure the pressure, he shuts, we wait 2 minutes and we make sure that pressure doesn't fall, and that tells us that all 15 of our oil valves are holding. So then after the 2 minutes, we go to the burner pair, you look it over, you make sure your limit switch is made, you make sure that everything's bolted in tight, you trick fuck the igniters as necessary. I say igniters. You trick fuck the flame scanners as instructed by the CRO. Then you say you're ready for a light. He'll hit a button. Then you go to chunk, and then your oil valve, and then your air valve. They come really close together. I don't think one's waiting on the other.
Normally the air valve hits first.
And then you get your spark rod, and then poof, and you get your fire in there, and then cha-chung, you move in that last bit, and that's it. Now you got a pair in. Man, this one's full of sound effects. All right, so then you get the whole row of those in, and that is one of your permits for putting in a mill.